In this problem, we're going to find the equation for the graph that's provided, and we're going to write our equation for cosine. First thing that I'm going to do is identify my high and low points, my minimums and maximums. And so I can see that I have a maximum when y is 3, and I can see that I have a minimum value when y is negative 11. And so what this will tell me is my overall height, which will then help me find the center of that sinusoidal axis. So I'm going to take 3 plus negative 11, and I'm going to divide that by 2 to find the center. And so this will end up giving me a negative 8 over 2, which is negative 4. So I'm going to draw in my sinusoidal axis at y equals negative 4. And so the sinusoidal axis tells us a couple different things. The first thing that it will help me find is the amplitude. And I can see that the amplitude, you always look at the distance from the center, that sinusoidal axis, to a minimum or maximum point. And so I can count the boxes here. This is 4, 5, 6, 7, which should be the same exact distance here. 1, 2, 3, 4, 5, 6, and 7. So I know that my amplitude is going to be 7. The sinusoidal axis typically is the x-axis. So if you look at the parent function for cosine, usually the center axis is the x-axis. So if I can find the sinusoidal axis, which is what we've done, I will know how far we've moved it, and we can see that we've shifted it down 4. So that's going to be our vertical translation is down 4. Okay, next we need to look out for horizontal transformations. And so I'm going to look at one full cycle. I'm going to look at these key features. Here's a maximum point, decreases, hits our minimum, comes back up to our maximum. The first maximum occurs at 60 degrees, where then it starts to repeat itself again at 960 degrees. So that tells me that the period is 900 degrees. The last thing that I'm going to look for is any horizontal translations. And so again, looking back to the parent function, I can see that this maximum point occurs on the y-axis. Well, now our first maximum point occurs when x is 60 degrees. And so that tells me that we shifted it right 60 degrees. And again, we'll call that our horizontal translation. So from here, we're ready to write our equation. We have an amplitude of 7. That's a vertical dilation, so I'm going to multiply on the outside of the cosine function. Next, I'm going to look at the inside, and so I'm going to change it horizontally, have a horizontal dilation, and so the period's 900 degrees. So to figure out the factor in which we're changing it by, I'm going to take 900 divided by 360. Since that's the normal cycle size of the parent function. We then can reduce that down, and it's going to end up giving us 5/2. So remember, anytime we have a horizontal transformation, we're going to write in the reciprocal. So our factor is 5/2, so in the equation I'm going to write 2/5. Then I'm going to start the parentheses. Our x variable we're using is theta since we're in degrees. And I'm shifting it to the right 60 degrees, so I'm going to subtract 60. From here, the last transformation that we need to write in our equation is the vertical translation down 4. And since this is a vertical transformation, we put it on the outside of the cosine function, and it's exactly what we would think, down 4. So we subtract 4, and we are done.